So lots of people wanted to cover materials and methods, so let's get going. In terms of material methods, let's think about it. So what is the purpose of materials and methods? So I'm just gonna go ahead and ask people who are here. Um, so Divnor, alphabetically. Oh, I don't know why Alvaro's not first. Divnor, what's the purpose of materials and methods?
It allows you to have a good plan in place. So if you like, when you have your good plan in place, you'll need a bunch of materials and methods to be able to enact and be able to move forward with the plan that you have in place. So materials, it can range in depending on the project you have, and also the methods as well.
Oh, yes, it could be used as a planning tool. I never thought about that. That's very good. Miriam?
Personally, for me, I find materials and methods, it's really good for reproducibility. So
Mm,
specifically, if I'm reading recent articles, just to see how feasible that approach is, I always start by looking at the material and methods.
that's perfect. Yeah, exactly, exactly. That is usually when you read papers and when you write papers, you do want to aim for you know, reproducibility and sort of like step to step, right? Like I always say like when you're baking a cake, how did you bake this cake, right? Okay. Um, all right, so let's get started, and then I'll show you some good and bad examples as we go along. So I will cover like, how we write up the method, and then, the input. So methods, people call materials and methods in like biological sciences, but usually in computer science, especially in our field of NLP, there is like explaining the method, which is like the method section, which is like the algorithm, the method, the system, the process, whatever like pretty diagram you can put together. And then there's the experiments, right? Like the proof that your method works. And that usually goes into like experimental setup. So there's two parts to it, like your novel method and then the experimental setup. And they're quite different, but you will see it in ACL anthology papers as examples. So the purpose of the method is to talk about what you did, right? It's very easy, right? Just talk about what you did and what you did to arrive at that conclusion. Now, in terms of reading a paper, a lot of readers will skip it, except for people who want to repeat your work. So people who want to cite your work, download your GitHub code and rerun it, they will read it in great detail. Reviewers who are going to review a paper will read it very, very carefully to make sure that the details are there. So you want to write it with great care. Make sure that it's not faulty, there's nothing incomplete, it's not unprofessional. Usually I say write it out in as much detail as you can. And then once you finish the paper, you'll be like, oh, well, we're over. If you're over, you can start moving things to appendix. But always in a first draft, just write. Like it can be 100 pages, we're okay. We can always cut it down. But always write as much detail as you can. In terms of the contents of the method section, you want just enough details for someone to repeat your work, so reproducibility, but also to evaluate your work, to understand and evaluate. It is not, do not include results. So none of the numbers, none of the discussion. It's just what you did, right? Like if you were baking a cake, it's just about the step of baking a cake. You're not going to be like measuring the height of the cake. You're not going to be like, this cake is delicious, right? Like, don't tell me any of that. Just tell me how you bake the cake. Yeah. And then in terms of talking about the techniques, how much detail, not so much detail that it is overwhelming. It's not like, so much detail that it's like an entire tutorial. I think this is where a lot of undergraduates might have gotten it wrong because they feel like, oh, this is like a lecture. Like when I take machine learning or when I take deep learning, I learn things from first principle. So I have to explain everything from first principle. No, just tell me the steps and don't explain neural networks to me from first, like don't explain transformers to me from first principle, from like I don't know, like calculus and linear algebra, right? Like just cite the Transformers paper or the BERT paper or I don't know, the Lemma paper, and then just put a citation. And then we can, go read the details of the implementation there, right? If you implement someone else's method for a certain step, just cite that paper. I think like Miriam's paper, right? Like I think you guys cited quite a number of papers. You stole, not stole, but we kind of Frankenstein a lot of different components together. So just need to cite that paper. You don't have to like re-explain it from scratch. Yeah, and like I said, in the first draft, write as much as you want, and then we can replace it later in the appendix. Okay. This activity is mostly for people who write algorithm and theory, so we'll skip that. But if you ever want to write like a very algorithmic theory or like pure machine learning paper, even data mining papers, it could perhaps require some of this. Okay. The organization of a method section, I will always ask you to answer this. So here's Snoopy, he's asking, where am I going? What am I doing? What is the meaning of life? So apply, Snoopy is trying to figure out, Snoopy, the dachshund dog is trying to figure out, what is going on. So you can imagine the paper is also trying to figure out what's going on. So you want to explain the purpose and reason of why you're doing something. So I hope you've written down several research questions or, hypothesis, and that can go into your introduction. But in the methodology section, hopefully your methods and your results and your conclusions will all point to answering this. So if you imagine like, the idea of all roads point to Rome, if you have your central research question and hypothesis, everything else then has to go into there. Your first draft, it might be not as organized, but by your second draft, third draft, fourth draft, it should be more focused. I know some of you are like, I write one draft and I submit and I should get it published. No. For my PhD, I had to go through quite a few drafts before I had a clear idea of what could be published. And there was a lot of reviewers that gave a lot of feedback that made me feel really depressed. But after you answer those questions, you come out the other end with a clearer and better research idea. Okay. Right. So always start with why you're doing something, then how it's linked, how you're doing it, and how it's linked to the central research question, and then provide any background information necessary to understand the experiment. Do not put your why at the end. This is what ChatGPT and generative AI does. It likes to add this like fluffy sentence at the end that has no meaning. It'll be like, I don't know, in conclusion, due to the significant, like, I don't know, due to A, we want to have significance in B, but usually it's like really wordy and really pointless. So do not hedge. Hedging is my most biggest pet peeve right now in generative AI write-ups. I think hopefully you guys have read enough papers to know what are some things that we do not want. So here's hedging, right? So here's some, so the research proved that students use generative AI in more than 90% of their assignments. So the research suggests that students probably use generative AI in more than 90. So, suggests probably. Yeah, so there's might have, often, some, many. So, modal verbs, some verbs, or often, frequency verbs, quantifier, some, many. So there's a bunch of examples here. I think I talked about hedging the first week. I still hate it, so that's why I'm gonna talk about it some more. Just biggest pet peeve, thing I hate the most. It's an area chair in NLP, or in ACL. Yeah. So, sorry. Yeah, so I believe that students use generative AI to write their paper nice and strong. Sorry, first person. It is believed that students use generative AI to write their paper, not as strong. Yeah, so you might tone down strong claims. So the variable is responsible, may be responsible. Results established. Results would seem to show that. This means it seems possible. These findings conclusively prove, appears to show, just like very, instead of looking at something very strong, this is like, very wishy. Just when you say something, say it, right? Don't say like, maybe, perhaps, I wish, very wishy-washy. Also, uh, our our novel design is well suited. Conclusive result shows. But you want to maybe like sometimes just make things, clear. Our results suggest that our design might be or is useful. So just be precise, be fair, and be respectful when you're criticizing people's work. Yeah, so there's a lot of examples here that you can look at, but these are all sort of hedging examples in academic writing. Yeah, so I won't go over it again, but here it is. I think I might need an entire hour to just spend on hedging in the future. Okay. Where's Snoopy? Okay, there's Snoopy. Okay, so in what order should you put the methodology section? It's very simple. Just put it in chronological order. That's what we usually do in ACL. In some different venues, you might just put it in something that's logical. But generally you have a beginning, a middle, and an end, like baking a pie, right? Like you buy stuff, you bake it, you eat it. Very clear. There should be like subsections with subheadings. There's a topic, sentence, and transition, with your purpose and background at the beginning of the paragraph as a topic and transition. Some people like to not have that transitional sentence in the beginning. I'm generally okay if you're tight on space, but try to put it in. Very important for a paper to have is to have a process diagram. So this is a very mathematical process diagram here, right? Every process diagram, make sure you have the list of terminologies or your legend, your definition of variables, you have equations, you have, oh, sorry. So make sure, sorry, just to be clear, make sure your paper includes a list of terminologies, right? Like the terms that you use, you discuss it with your team and make sure that is clear. Definition of variables, your X, Y, Z, ABCs. A list of equations that you're using and machine learning equations that you're using. I think Qifeng's team will do an excellent job in that. I worry that the HCI team might not do that, but that's okay. A very strong figure 1, which is like this process diagram here. And it'll be good also to have like an algorithm, like a pseudocode of your process. Now, some of you might think, oh, why are you making me do this? But when I see this in the paper, it automatically signals to me as a reviewer and as an area chair that this is a strong paper that has been thought through clearly and very methodically so that, everything is clean and clear and well argued out. When these things are missing, your paper doesn't present as your strong. And even if you, don't do this and maybe like put this at the, I don't know, at the, you don't do this but put it in the appendix, at least it still shows that, you had the training to do things right. It's sort of like, when you watch a soccer team, somebody who's well trained in skills versus like maybe, I don't know. I think probably I won't offend anyone. Probably all the World Cup teams are very, very good, but some of them probably are trained in like skill sets, right? And you want to see that, they have the basic skill sets, things like terminologies, variables, equations, figures, and algorithm pseudocodes. Those are things that I want to see in the paper. If your paper runs long, that's okay. We can always move it to the appendix. So here are some examples, right? So here's a reproducibility example. SIP 200, I think we're closing in tower like 150 citations. So hopefully by the end of the second year, we'll get 200 citation. 100 citations a year is not a bad thing. Mm, you know, it's on paper with code, but it's also on Hugging Face. It's getting cited a lot because it's very easy to find and very easy to download. Here's a very nice example of a figure 1. Here's some lemma models under 3 different writing systems and 2 different languages. The colors so the input colors are the languages. The output lemmas here are the different writing systems, and you can see like we fine-tuned it based on a bunch of different methods. So there's a very clear legend and really cute pictures of. Sorry, I'm a sucker for the cute picture of lemma, but a good process diagram makes a difference. Here's another example of 6 different models that went into a HCI example. That's what Aaron and Sonia's work is based off. We also have proxy LM, which was cited for a keynote speaker at a conference. And so you can see that the equations are defined. And then you can see that actually one of the reviewers complained about one of our equations because we didn't cite the original paper properly. So I think this one here could be, yeah, so they caught us. So we got caught. So we had to go back and cite it again. But you can see like all the equations are properly defined. They want to see that. And the equations are also in the process diagram again. And we actually define things properly. So you can see that proxy LM is the name. You can actually define that as a variable in LaTeX. And so that you don't have to, because sometimes you don't come up with the name of something until like right before the paper's due. And so instead of going through one by one changing it, you can always just define it as a LaTeX variable. So we said that it's a proxy model. And each of these were defined, right? Like, we had to define like we had to define these scores, we had to define features, data features and language features. We had to define like, regression terms and objects or metrics. Like all of those had to be defined. So a part of your methodology process is having a list of terms and things that you're using, your variables, your equations. All these will really help you write up different different auto hyperparameter optimization or auto ML various components and sort of compare the different variables. I think this should probably go, but you don't truly know that unless you understand your method fully. So here are some important principles of the writing the methodology section. In terms of the grammatical voice, you can use passive voice, but just make sure, or you can use like we did this, we did that, but don't switch your point of view, right? Once you pick one, stick to it. In terms of tense, anything that you did in the past is past tense, but things that are generally true, you can keep it as present tense, right? Like in this figure, we can see that the relationship is positive proportionally. Like that's positive because you're observing it. Or facts, right? Like the scaling law always holds. It is true. It's not like the scaling law held. It was true. It's present tense. In terms of word choice, avoid jargon, redundancy, use precise word choices. So you might notice I'm very picky on how people use work, which is why, generative AI and ChatGPT drives me crazy because the way it picks words is not very precise. And it's all very like, it's based on a distribution of whatever came the most in a particular. So there's a lot of research papers. Oh, I don't know if I show it here, but I think I show it in the rebuttal section. But there is evidence of certain words just skyrocketing after ChatGPT came came into being. And so then those are the words that ChatGPT uses a lot and people use it in their writing. So here are some examples of very precise word choices. And often when I'm reading a paper, I will highlight a word and say, get rid of it because it's clearly from ChatGPT or from generative AI or from Claude. So I'm very sensitive to things like that. I apologize. Things that drive me nuts. I don't mind you using AI, but just don't be so obvious. Yeah. So, words like determine, right? To investigate, calculate, experiment, survey, study. Measure, right? You're actually measuring something precisely. To calculate, you're actually working on some numbers and computing something. Quantitate, so again, measure precisely. Quantify is to measure a quantity. So there is many, 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 many more words from phrase bank. You can pull out definition list, you know, I like precise wording. So pick it carefully. Um, so here is I feel like I taught this recently. Sorry, Miriam, you must have seen this already before. Okay. So tell me, why is this a bad example? So I think I finished at Miriam. So Nazar, why is this a bad example? I already gave you the answers, but tell me why.
Um, I think the choice of the word is not correct, or it's bad.
Yeah, there's definitely hedging. Sorry, next person. Qifeng.
So for the highlighted part, especially a small part, you should not using a small part. You need the quantitative description of how small it is, I feel like.
I love that. Yes, that's something I always complain about. Tell me how much. Don't say I improved a little bit. What is a little bit? Great. Thank you, Qifeng. Santiago.
I guess I don't see well, I'm not sure the format, but I guess I would rather have the references to the tools I'm referring to.
Yeah, y'all love Coco. Like you need to name these so you need to name fully the acronyms and then also the citations. And
Mhm.
also, an object detection model. Like what? That's like a little bit random, right? Like they didn't really introduce us as. So I used to teach MSCAC, which is like, 120 to 140 master students who each had to write a final research report. They all have a research internship. I would say top 10% of students publish their work. This was one of the worst internships. Like last person to submit, last person to graduate, almost didn't graduate, couldn't go back and redo their experiments. I don't know what they did for the entire 8-month internship. It was like really bad. Did not get a return offer to their job. Okay, here is somebody who did really well. So next person, Sonia, you get the easy job of telling me why this paper was so nice.
So they include diagrams. Um, they have like, in neural sparse voxel fields, they add the acronym after it, so then they can reference it throughout the paper, and then they have references too, so it's more specific and to the point.
Yes. Okay, so maybe you guys can see my answers, but yeah, like it's very clear. And there's even a research question and how would they answer? And look at the nice subtitles headings. This is exactly everything I said. So they obviously follow my slides. This is a very strong intern. They got a really good return offer to Samsung Research. In fact, this particular work was published at a computer vision conference in Hawaii. So lucky him. Samsung sent him to Hawaii. Not bad, not bad. In December. Uh, what a bonus. Um, and when I went through this with the student, they actually went through and actually double checked that this image will come. People who work in vision, they're like picky about the quality of their image. So we actually tested that this image will show up nicely on an area poster. So those of you who are based in Toronto, definitely go to MSCAC's ARIA symposium. They will print and all of you submit your work to ARIA so that you can present it in Toronto. I think all my best students who end up in grad studies or publishing papers showcase their work there. And it's just like such a huge venue, such like lots of people come by to look at your work. Even like there's all the top industries because there's 140 interns, like top quality research interns and companies, and it's just great network opportunity. And they print the poster for you. I wish we could keep it, but I don't know what happened to the posters. But yeah, so the students actually went and checked that this poster was high quality. So every year my students go and they do a demo, they request for a computer screen, they do the printout. It's amazing, just the best experience. Okay. So common problems of the method section, if you don't have enough details for reproducibility, you didn't tell me why or the purpose. If you switch between passive active, right? Like using we did this and versus active versus like it was done. And then past tense and present tense, you keep switching back and forth. So there's a checklist. So for every single section, there's a checklist that you can go through and check on your own as a team. Generally, these are things that my PhD TAs found when they were grading master students' final reports. So grammatical errors, your figure doesn't have the caption, you didn't explain the abbreviations. If it's too detailed, I will just like tell you later to move it to appendix, so don't worry about that. Passive voice or too many I's or mixed tenses. The motivation of why is not clear. Like why you're doing something needs to be really like first sentence. Make it up front. Equations not being clear, your variables are not clear. Adding results in your method section, make sure your results are in the results section, not in the methods. Make sure now some things is like, having nice transition words. Some students also don't know what introduction and methods are. I just taught you, so and then incorrect references. I have to teach this every year. I don't know why I have to teach people to do references properly every year, but yeah. ChatGPT, do not use GenAI to do your references because if you're caught and they publish it online, we are forever blacklisted. That is something that I have been checking for at NeurIPS. So dangerous, very, very dangerous. Okay, great. Okay, so as promised, I said we will take a look at some of the results. So I told you last week, why it's important to have the results. So I'll try to cover a little bit of that, and then whatever we don't finish, I guess we can continue the week after. And Sonia, I promise you we will get to project management soon. Sooner rather than later. Okay. Okay, so and every year I tell myself I'll teach this course in a more organized manner, but the ARR deadline gets me every single time. And I end up teaching to a deadline rather than in an orderly fashion. Okay, so results. So last week I showed you the results, and here's my why cat. Why are you doing something? How many people here have to benchmark the runtime of their work?
Sorry, what do you mean by runtime?
Oh, you have to benchmark. You have to benchmark runtime, Sean.
Yeah, I have benchmark, but like, sorry, what do you mean by runtime?
Like how fast your algorithm runs.
Oh, I actually did not do that yet.
So you and Miriam probably need to do that. Miriam, you Divnor, Miriam. Maybe Santiago?
I have the logs of the time run. So
Oh, very nice.
yeah.
Yeah. Okay. Yeah, so this is just a quick aside to the results. I taught you results, but sometimes in benchmarking, you need to measure runtime. I think this is really outdated, but in algorithms, we used to, you will use big O notation. And so you will have like your algorithm plus big O. But here you can like just verify your code by adding some, flops, your floating point operations. So you can have some static cost analysis, which is, the floating ops, or maybe like your big O notation. Wait, when I say big O notation, because everyone's from different countries, who here does not know what big O notation is? Raise your hand, then I'll explain it. Okay, great, because I don't know what people call it in other countries. Okay. Yeah, so obviously you want to make sure your code compares properly, and the runtime just lets you do a sanity check sometimes, right? Like obviously, like especially in Miriam, because you're combining different components, sometimes it's useful to have your runtime logs or measure your runtimes. But nowadays, Python does things like there's packages that does that very well, especially for like machine learning. Okay. And different algorithms might have different operation counts, but how many people have measured things this way before, like with C clock or get time of day? How many people have actually measured runtime from the old school ways of programming? No? Okay. So how are you measuring runtime, Santiago and Miriam?
I just have. Oh, sorry.
No, go ahead, Santiago.
I have basically I don't I have like a lot of information in my code, so every time it runs through a cycle of the alignment step, I think the timestamp. If not the other thing I have is the in the logs after during the realignment it will say this like this specific part ran in X amount of time.
Is this something you added or was there already?
I'm not sure. I think no, I think I added it for my projects, but maybe Kwan had like a little yeah because he saved the logs. I think the printing was mine, but yeah.
Very, very good. Yeah, so it's important. It's important to have, yeah, so some of these runtime ideas. Miriam, how are you measuring your runtimes?
I do the same where I'm measuring duration. Kosei recommended this just as a sanity check because if something's taking too long to run, you might just be doing it inefficiently or there might be a bug.
And have you found anything? Any bugs or inefficiencies?
Luckily, no. Luckily, we were good on the time.
Oh, good, good, good. Yeah, I think Jose's gone through. He's ran a lot of papers and had many conversations via GitHub with a Korean PhD student. They've never met each other except through conversations on GitHub until the invited speaker series. So this is some good like experimental setup ideas for you to do, have some runtimes. Here they're measuring ML flops, but you might measure like milliseconds or other things, and then you can do size or log size. Here are some information. So there's the machine. There's a specific compiler. Anyone here has taken compilers, the course? I think if you've taken compilers, all of this is like, no one's taken compilers? It's not a popular thing to do anymore? Okay.
No, it's popular. It's just that I just got the prereqs for it.
Oh, okay. How many people here has taken operating systems? One person, two? Okay, a couple of you.
I do,
Okay.
but I can't raise my hand.
Okay. All right, so I guess compiler is not really needed, but it's a good skill set. Okay, so part of the so I'll just keep going until we have to go. So part of the important part of the results, once you run your results, you benchmark your times. You have to decide whether you want to show it in figures, graphs, or tables, right? And so imagine you keep a notebook with lots and lots of raw data, right? I ask you to keep raw data in spreadsheets, or in imagine if you're in physics or chemistry, you'll write it down in a notebook. So I'm asking you to keep all this information, and then you will have the important question of how do I slice the data to make it into informative graphs and informative tables to get my message across. What's the message? Your message is the research answer to your research question and your hypothesis, right? So whatever answers your main question will be your main finding. So you want to make sure that you highlight that key finding for your readers and get that main point across. So any graph, table, figures has to be standalone on their own in a paper. So everything about that graph needs to go into, the caption or the description. And you have to decide how you're going to present it, whether in a table, a figure, a text. But obviously, you don't want to show like 20, figures and tables, right? You want the least number to tell a story. If you're not sure, just try many different ones and then present it to your co-supervisor, your supervisor, to your team, and just test it out on meetings, which one showcase things the best. So that's why for all of you, I mean, most of you already have results that you're showing, but Nasser, and that's why I keep pushing you. It's like, what is the research question? What are the results, right? Start showing me some of them, and let's start discussing them, because that will really determine how fast we can iterate and come up with some significant, impactful work to tell, like a good story to tell. Remember, we're not really like, we're trying to tell a good story, right? So this really matters. And when reading a paper, let's see, do I have a paper open? Yeah, here's an archive paper I haven't opened. I don't know why. Oh yeah, so this is a paper we wrote. Very well done. But when I don't always read a paper right away. My first step is to skim a paper, right? So I would look at the title. Is it a good title? Obviously, I won't know any of this because that's all hidden to me. I'll read the abstract, but I will look at figure 1. Doesn't make sense to me. My complaint about figure 1 here is that there isn't a legend and it's super short. Like, it needs to be very clear description here. And then since this is a workshop paper, it's lower quality anyway. And then, here's another figure with a very, very detailed, description. So I like that. And look, it even has like italicized, proper definitions and names, proper, legend here. The tables, I want to see the tables make sense to me. It tells a story. The statistics was done by Adia, who's going to direct PhD at Columbia for statistics. He's going to be like a statistical person. Columbia has like David Bly, who created topic modeling, and a lot of like famous Bayesian method people. So you can see like a very clear graph. And also, the tables tells a story. It shows me the increase, color differences, very clear legends. Another really clear table. We tried many different graphs, right? Like this is the graph that he settled on, Being in stats, they're always good at showing pretty results. But, this was a combination between 3 PhD candidates, right? One in stats, one in HCI, and one in NLP. So they did a very good job. So this is another table. And I think this was like originally, I think this is one of these tables, but in table form. Here's another table. So you can see that, a quick evaluation of this this paper. If we run through, that's how I would skim a paper. And once I skim that, then I'll start reviewing the paper if I'm reviewing it, or reading the paper if I'm reading it. But if any of that stuff looks unprofessional, or any of that looks, I don't know, poor quality, it gives me a bad impression, and I'm automatically going to rank the paper lower, or be less likely to want to read it, or, if it has mistakes and things like that. Okay. So that's why, figures, tables, results, very important. Okay, so the type of figures, block diagram, I always want to see a process diagram of what you're doing. So make sure that you have one of these. This is Big Bang Theory, Dr. Sheldon Cooper's friendship algorithm. So, here he's trying to make a friend, right? Like, this is back in the days when people had a phone and answering messages. Very old school. Leave a message, wait for call back. If they call, then, would you like to have a meal, dine together? If yes, begin friendship. If no, then would you like a hot beverage? If yes, then what kind of beverage? And begin friendship. If no, then, is there other activity that we can do? Is there a shared interest? No. And then he was stuck in this infinite loop until his friend says, after 6, just pick one that you guys least objectable interest, and then begin friendship. So this is Sheldon Cooper's physicist, probably slightly autistic physicist friendship algorithm. Again, I always talk about these diagrams that I like. Okay, so you should decide whether you're going to use a graph or a table. So you choose a graph when you have trends, you have enough data points, if there's a hidden relationship that you want to choose. Choose a table if you have a lot of information, if you're comparing different groups. Maybe you just want to highlight the best, that would do. I think I briefly went over all the different table types. Usually I play a really nice game, but ARR is looming, so we will end there. Okay, so remind me. So next week at the beginning, if you can remind me if there's something urgently that you want to do. Otherwise, we'll do discussions and conclusion, and then we could potentially do like abstract and title. We can try to cover all of that next week.